Hey, good morning, everybody. Welcome to the Temporal flagship meetup. We have a cool agenda for you. But before we get started on that, let me get through the monthly announcements. So first off, very exciting, the Temporal Replay CFP, our conference, the call for proposals, is open. So if you have any ideas around temporal, around durable execution, around cloud programming models, and you want to share with the community, present at Temporal Replay. So please do all flock to the CFP. It's open now, and submit your ideas. We are super excited to see what's coming. So that's number one, CFPs, please. And number two, we have meetups coming up, and there may be a meetup also in your area. So do visit the address for the meetup and check it out for the exciting in-person temporal meetups that may be just around your corner. Now, after getting through this, we have a cool agenda. First off, we have an SDK Fireside chat. And then second, we have a TypeScript demo. And obviously, we cannot just have only one emoji. We have definitely two emojis. So we have a Fireside chat next to the fire, and then we have a TypeScript demo that will take off like a rocket ship. All right. And with that, I'll hand it to Jessica and Chad for the Fireside chat.
Awesome. Thanks, Dominic. Hey, everybody. I'm going to just pin Chad and myself as soon as I can find it on Zoom. Watch me figure out how Zoom works. Actually, I think, Dominic, can you stop sharing your screen for a second? Perfect. Thank you. And I think if this should work. Okay. Can everybody see the two of us? I think it works. Yes. All right, cool. Hey, everybody. I'm really excited to chat with you here today. So I'm bringing on Chad here to talk through a little bit of like what we've got coming up on some of our SDKs. And then also, to open things up for any of you. So I've got a couple questions I'm going to ask him. And then if you have any, please feel free to put them in the Zoom chat or Slack, and we'll make sure to bring them up. So a quick intro. So my name is Jessica West. I head up the developer relations and community team here at Temporal. I'm really excited to have Chad here. And Chad is a software developer that focuses on the SDK team and does so much for the Temporal community. So really happy to have him here and chatting with us. Chad, I feel like, is there anything else you want to say about your intro? I just did a very basic one.
No, you did a good job. I'm Chad, default SDK guy, and I get to do all the fun stuff and write all the languages.
Awesome. Okay, well, actually, that's great. So we can kind of catch up, kick off with talking about some of the fun things, like what's kind of your favorite problems to solve at work right now? Like, what are some of the cool things you're working on?
I would say in general, myself and the rest of the SDK team have the cool job of working across languages and language runtimes. I would say the most interesting problem, and it's pervasive across all the time, it's not just today or what I'm working on this month, is trying to prevent people from shooting themselves in the foot with determinism on workflows. Some language runtimes allow us a lot of flexibility to mold people into the right way of doing things, and some don't. So it's a really interesting problem, from static analysis to runtime sandboxing to many other approaches on how best to put guardrails on things.
Nice. And so like when you're thinking about like putting those guardrails in process, like how are you best getting feedback from the community and things of like what's working, what's not, how you can be better, things like that?
Yeah, so we actually rely on Slack a lot and our public forums a lot. So please communicate with us there. But it's mostly there. A lot of times, and anybody else working on software projects knows this, if it's not broken, you'll hear crickets. So our primary feedback is actually through GitHub issues when things are broken. But as far as for trying things out, we asked many popular users, bigger users, and just in general, the community to give feedback as much or as often as they can, specifically about those sandboxing parts.
Awesome. Yeah. And for those that, if you're not on our Slack group, we have a community Slack. And so everybody's pretty active in there. So if you have any questions, you can reach out and chat in there. Not just right now, but just in general, on finding out some more information about Temporal, upcoming events, like what we're working on the SDKs, ask any questions. So we've got that and the community forum. So we've got a couple places for you to ask some quick questions. So thanks, Chad. Awesome. So on the SDK team, we've got a couple languages that we support right now. Can you walk me through some of the SDKs that you've worked on or something that that you work on specifically or with the team?
Sure. So I work on a little bit of all of them, but primarily I was the steward of the Go SDK for the longest time, which is our oldest one. And then I wrote the Python SDK, which is starting to gain some popularity, and it has a lot of very cool features that fit Temporal very well. And while maintaining and stewarding that SDK and the Go SDK, I also am now writing the .NET SDK, which also has a lot of very neat features. So I have a lot on my plate at the moment. And then, of course, obviously we have Java and TypeScript. I'm not the primary steward there, but our team is.
Nice. Awesome. So then the Python SDK just was released. So can you tell me a little bit more about the development of that SDK?
Sure. So SDKs, when you use the word SDK or use the word client or term client side, people tend to think, okay, thin wrapper. Well, as everybody here that's worked with Temporal knows, these SDKs are big, complex beasts, and they take a lot of time. The Python one in particular took probably around 9 months from conception to general availability. The primary reason is actually not the code. It is the review, because there is so much involved in the state machine. And really, the only reason that it took only 9 months, if you can say only 9 months, is because it's backed by a Rust core that also has been, under development for years. And so same with the .NET SDK. So that's how the development progressed there. We essentially did feature after feature, alpha after alpha, getting feedback, and also using the proposal mechanism that we have that is publicly available for anybody to comment on to clarify what we plan to implement before we implemented it. And Python, just like all languages that we build SDKs for, requires a significant amount of research to make sure that everything we do is ergonomic with the language. So it's not just be consistent with Temporal, but it's important for us to fit how that language feels.
Nice. Yeah, I think it's great. It's funny. I think so some people like looking on the outside of like, oh, I'll pop this language here and there. But there's a big difference for how you're using this and even how our system can work depending on the language based on the styles of things. So yeah, I think we've got actually a Python conference that we're heading up to to PyCon actually in a month. I think it's a month. Yeah, actually, and go to the meetups. So super excited to hear and engage with that community as well, and get some feedback on the SDK. So I think you mentioned for getting feedback on that, that's mostly going through GitHub issues right now, opening that, or just checking on Slack and anything, correct?
Correct. And I and the rest of our team pride ourselves on how quick we are on Slack during business hours. So I'm literally happy to chat about anything at any volume. Nice.
Yeah. And business hours, you're based, you're in the States and in East Coast time zone? It's
Central. Mm-hmm.
Central. Okay. The middle of the world or America. Mm-hmm. Awesome. Very cool. All right. And so also, and if anybody has questions, feel free to jump in. Otherwise, I'll just keep peppering Chad with questions here and there. Can you share a little bit more what you said you were working on? You just released the Python SDK and you've worked on the Go SDK before. What's something that you're working on right now?
So right now I am half doing the Python SDK. Obviously, all these SDKs require an immense amount of maintenance They're pretty complex beasts, and we're always, putting out new features. We just put out schedules. We're going to have synchronous update for workflows coming right around the corner. So Python maintenance. But most of my days is knee deep in C# these days, writing the .NET workflow portion of the SDK. The SDK is about 3/4 done. It's going to be full featured in a couple of weeks, but it's going to remain alpha for a little bit while I wait on feedback. Like for instance, this morning, I'm figuring out how best to expose async stack traces to our stack trace query, because they don't make it very easy in .NET to do that.
That's fair. Yes, you said you're about 3/4 of the way through for .NET.
Yeah, I'd say so. Maybe even a little bit further. I'd say the main things that it's one of those 90% done, 90% to go type of deals.
Yeah,
a lot of samples. A lot of samples, a lot of ducks coming up.
Yeah, awesome, cool. And just some questions for that. We'll put that one. Can you tell us a bit more about the upcoming synchronous updates from the features of the SDK from Anthony?
Sure. So everybody writing workflows know, and I personally think, and I'm not really the marketing arm, but I personally think this is the largest feature that Temporal has ever developed. As far as significance. So everybody is aware of workflow interactions that are signals, which are unidirectional, but can mutate state, and queries, which while bidirectional are immutable. But there's no request response mechanism for workflows. This changes that. And it changes it in a very significant way, almost as a superset of both signals at least. And so I think it's going to take a while for everything to get developed, because it is a very complex feature, but it is very, very important to Temporal.
That's awesome. And from like that, is there anything else like actually Lauren asked a question too. So are there any of the challenges that you've run into working on the .NET SDK?
Sure. So let's see. I'll tell you my most recent and most annoying .NET challenge right now is that our workflows are coroutines, and they're essentially single-threaded deterministic coroutines. And some languages like Go or Java don't really have an easily pluggable scheduler, but languages like Python and JS and .NET do. However, unlike Python, I don't get full control over the .NET asynchronous task event loop. I can only have certain parts of the scheduling. And .NET chose to make all of their default task scheduling to use the default scheduler, which uses the thread pool. And you can't use threads in workflows. So I had to build this whole tracing thing to add these guardrails to keep people from accidentally submitting tasks onto a non-deterministic thread pool. So that's the biggest challenge for me, is that .NET task scheduling is not pluggable very well.
Awesome. Thanks for walking through. Looks like we've got a lot of other questions coming in, so I'm going to work through these. Okay. So with this one, actually, I'm just going to double check. Cornelius, what was the important feature you're emphasizing? You didn't catch it. Is there any place we can see more? I think everything's like planned up on the open, right?
So we work in the open. The major features missing in Python SDK compared to Java and Go are pretty much none at this point. We've hit just about feature parity. Now, there's a couple of features in Java and Go that we've intentionally not carried over, such as sessions from Go and side effects and mutable side effects for both languages. Both of them have reasonable workarounds, and we have to stop and think about how we really want to accomplish those across multiple SDKs. But otherwise, we shoot for feature parity like across all of them. So when I drop .NET here in a couple of weeks, it'll have full feature parity with those other two as well.
Awesome. And then do we have a plan for the Swift SDK?
No, and I'll answer the Rust and Swift one at the same time. No,
okay.
And that goes for, Elixir, C++. Like there's so many I'd want to build. These are so incredibly complicated that it is just not reasonable to maintain ones for, and I'm not about to call Swift an esoteric language, but for less common languages, what we'll start to recommend is that people find ways to build the workflow in languages that we know or that already exist, and find ways to invoke activities and external things via FFI or, your favorite remote calling mechanism to these other languages, because it's just unreasonable to do them all. And as far as Rust goes, there's probably even more of a plan for Rust than there is for Swift, yet there's still no plan. It would be too far out to even speak of one.
Yeah, fair. So with all this work on the SDKs, is there anything like once we're working on like Python.net, and we're finding these different opportunities for Temporal, is there any improvements that we go back to the other SDKs? And if there's so, is there an example?
Absolutely. So we learn about things that people, it's actually not usually language driven and runtime driven, it's people driven. And once you start going into other language SDKs, you start to introduce yourself to new groups. For instance, the ML community is not very thick in Go, but it's very thick in Python. Or like the banking community may be thicker in one than the other. And so, for instance, let's see if I can think of an example. Yeah, so like a couple months ago, people were like, look, we want to encrypt our failure messages and our stack traces transparently. We don't want, like we can encrypt everything else. And it just wasn't a thought in the Go SDK because nobody had really asked for it. So that's something that, we get together as a group. We're like, every SDK needs this, and we disseminate the feature across all the SDKs.
Yeah, awesome. I think we got like Pepper. I think we answered everything. Well, you answered them. I read them and you answered them. Awesome. Does anyone else have any other questions for chat? No. So yeah, anything else, Chad, like that you want to highlight from like you or your team what you're working on? I think we've got about 5 more minutes before we have to pass the baton to Lauren.
Yeah, so I would say there's no need to be shy about the feedback, even if everything's working well. In fact, especially if everything's working well, and that includes existing SDKs, regardless of the age of the SDK. We will take all feedback, good and bad. Some things we can't make alterations to for backwards compatibility reasons, yet we would still love the info because sometimes we can document away things. So please keep in touch, show what you built, say what's annoying or what doesn't work well, what you'd like to see. Those are invaluable, and those are the primary things that keep us from getting to GA on some of these newer SDKs.
Yeah.
Here's a question from Jacob.
I know.
I suspect he knows the answer anyway.
I know. Yeah.
So he's asking, how do we test all the SDKs for feature parity? Well, originally we just kind of had a big table and we shook each other's hand and said, okay, you're doing this, I'm doing this, blah, blah, blah. And they all had their separate integration tests. But we've been actively working on a conformance suite. And a conformance suite has many more benefits than just checking conformance of SDKs. It essentially has all of the languages implementations of a certain feature right there next to each other. So it kind of serves as a Rosetta Stone if somebody wants to know how to do it in one language and the other language. This repo is called Features, and we're slowly building it out, but it, in essence, becomes documentation of every single thing that Temporal supports because it's a conformance suite.
Awesome. Thank you. And then we have a couple of questions. Let's see, going back. Someone recently upgraded from 1.0 to 1.2 from 1.19. I'm using custom search attributes, but they're not available automatically in 1.2.
So that one I'm going to refer to like a more legitimate support route because I don't know that we can really answer that over a chat very easily. However, there was search attribute changes. I'll go ahead and mention the search attribute alterations. They probably affected this, but it shouldn't affect most people. They were supposed to be transparent. But in general, you don't have, if you're running your own server, you don't need Elasticsearch to get the benefits of search attributes anymore, which is a huge benefit to 1.20.
Yeah. Great, thanks, Chad. And then we'll post like everything if you're unable to find support easily, like we'll post that URL here in a minute as well for everyone. Great. And then the other question from Frank, are all SDKs open source and available for community contributions? And if so, how do we get involved in the development of the SDKs?
Absolutely. It is like the most important thing to me and all the way up to our CEO, right? It's MIT license, not even GPL. It's so open for reuse. We constantly encourage contributions. Open a PR. Yeah, there's a little CLA that you have to sign, which basically just says that you're willing to transfer ownership just for copyright reasons. But in general, it's all MIT license, all wide open. We strongly encourage contributions. Any way that you can give them, we'll take it.
Awesome. Great. And then, we'll cover, I think, probably the Cassandra, Elasticsearch, and anything else while upgrading. Is there anything, Chad, you want to talk to, or you want to just have them go through?
No, I think that, yeah, that becomes more of an ops server upgrade type of question, not as much the language runtime.
Perfect. Yeah. Awesome. I think we got everything. From that, I guess I will say thank you, Chad, so much for your time. It was really great just chatting with you, and I hope everybody got some great benefit from this. We have a lot of great things coming down the pipeline that Chad and a lot of the SDK team and really the engineering team at Temporal are working on. And then we're really helping to bring that more to you wherever you're at. So like Dominic mentioned, we have a lot of meetups happening around the world. And so you can go to the events page that I posted in the meeting chat earlier, or follow that QR code, and you can see some things happening. So we've got our replay conference coming up, which we do offer new speaker training. So if you are excited about something and you maybe are a little anxious about talking, please let us know. We're happy to walk you through everything and bring you on board. And we have the meetup. One of them is actually in London in 2 days. So if you are awake, well, it's not too late in London. If you're there, feel free to check it out. Or if you feel like buying a plane ticket last minute, we won't stop you. So, and from that, we're looking forward to hearing next from Lauren. But in the meantime, Chad, thank you so much for your time. And we'll see you on the Slack.
Yes, don't be a stranger. Come say hi in Slack.
Awesome. Thank you.
Awesome. Thank you very much. And as Jessica, oh, sorry, my voice is failing me. And as Jessica already mentioned, what is happening? Now it's Lauren is now taking off like a rocket ship.
I was so we'll bring on Lauren. I got you, Dominic.
Thank you.
Voice is gone. We'll bring on Lauren to talk a little bit more about what they've worked on with the TypeScript SDK and some demos, and showcase that a little bit for you. So really excited to have Lauren take over.
Hey folks, my name is Lauren. I'm on the DevRel team along with Jessica and Dominic. And last year I worked on the Node runtime, our TypeScript SDK. And so I've been writing some blog posts and sample applications using that SDK. And I wanted to show one of them with you and go through the code. So here's the first blog post I wrote in January. You can find it at temporal.io/blog. And I introduce durable execution and what types of distributed systems issues it solves. And then I talked about our SDK. And I'll go through the app and then look at the code. And you can get the code by running this command, npx temporal io/create at latest, and then the food delivery sample. So looking at the demo app, it's a delivery application like Uber Eats or DoorDash or Instacart. And you can order an item like burrata, and it starts a workflow that represents the order. And right now it's in status paid. And then we can go to the driver portal. And the driver can say, oh, there's this new order for burrata. It's paid for. I can say, all right, I just picked it up from the restaurant. And okay, now I just delivered it. And status delivered. And so if we go back here, the user in their order application can see that it's delivered. And we can order some more items. And they start out in charging card status and then hidden activity to try to do the charging. And sometimes they fail with couldn't reach the payment service. And if you don't pick them up within a certain time period, then the order will get automatically canceled, and we can see that in a moment. Right now, I've taken this npx command and run it locally, and have it in this VS Code window, and we can look at just generally how this repo is set up. We've got the package.json with some workspaces in the apps folder and the packages folder, and then we use a turbo repo as the monorepo runner to run things in parallel. The build scripts from each of the workspaces, etc. And then in terms of the building and starting order, you tell turbo repo with this JSON config file saying like running dev depends on build. Running the worker build depends on these two other workspace packages. So let's check on our app to see. All right, so we had Barada was like picked up and ready to deliver, and both of them failed because we didn't pick them up or deliver them in time. And we'll look at what that looks like both in the code and in the web UI. So, all right, we've got 3 apps. The menu app, which is a Next.js app that is this website. The driver app, which is also Next.js with this website. And then we have the temporal worker. And both of these apps also have the backend in like Vercel serverless functions in the Pages API directory using tRPC. And the worker is pretty simple. It's calling starting workflows in this package and activities in this package. And there's some shared components like config files and UI components and common files for setting up the connection to Temporal Cloud. So going from sort of the start of the flow, when we click an order button, this is the menu application. So we are inside of this menu app right here. And we are, let's see. Let's look at the index page. We've got a list of products. And when you click on the order button, this on order callback gets called. And that calls order.mutate. And order is a tRPC function. If you're not familiar with tRPC, it's like a way of doing API calls in TypeScript, full stack TypeScript inside of a monorepo. It gets to really, really easy because I can go to definition. And let me do this with the mouse so you can see what I'm doing. But if I go to definition I was inside the index file. Now I'm inside the API route on the server. And I can change this like create order foo and save. And if I go back to my front end, it's like, did you mean create order foo? Because there is no backend API called create order. So that's a really nice way to connect the two. I can also refactor. Let's do rename symbol. Create order, enter, and then it'll be automatically changed over here. Similarly, you can get automatic type inference. So this create order function is returning a string. And on the front end, if I want to look at what the return value is, then it's automatically tells me it's a string. And similarly, if I change this to an int, it'll change to an int. So I guess that's tRPC gets translated into functions that hit this API route, and you can have really nice typing and DX in your editor. Now, in terms of what this create order function does, so when you click it, this gets called, which sends a HTTP request to the backend, which this handles, and it like validates the input format, and then it calls this handler. And this temporal is the TypeScript SDK client instance that translates this start command into a gRPC start command that sends it to the server. And we say we want to run this order workflow with this ID, and I want this product. So once that happens, the worker will pick up the task. So we've got the worker over here. Worker's pretty basic. It's just getting the workflows and activities and connection from elsewhere. And if we look at the definition of the order workflow, so we did go to definition that searched us into packages, workflows, order. And what do we have in this file? We've got the state of an order. Starts out as charging card, switches to paid, picked up, then delivered, then and sometimes refunding. So if you wait longer than a minute without picking up or delivering, then it does compensation refunds, and then it's in refunding state while that's happening. We've got two signals, a picked up signal and a delivered one. That those are called when the driver hits the pickup button and the deliver button. And then we have a get status query, which returns order status object, which has the product ID that was ordered, the current state of the delivery, and sometimes the delivered at timestamp. And then we have some activities: charge the customer, refund an order, or send a push notification to the user. And then here's the workflow function. It doesn't return anything. It takes in the product ID, and it starts out looking at the product ID. If it can't find it, it fails the workflow by throwing an error or throwing an application failure, and starts the state out and charging card, and then sets up handlers for the two signals and the query. So whenever we get the picked up signal, we just change the state to picked up. Whenever we get the delivered signal, we change the state to delivered and update the timestamp. And whenever we get a get status query, we return all of our local variables. The business logic starts out charging the customer, and we can look at, go to definition, activities. All right, so we just went to definition and opened up the activities package. And this calls the payment service with the number of cents. And if we go to definition on payment service, we see we are making an item potency token that we're going to pass. Like if we had like a stripe.charge, we would have like something like that. So we would pass this to whatever payment API we're using. And in this case, we're using the workflow ID dash charge. So this activity will always have the same token when called from this workflow. If it's too expensive, we say we give a permanent error, application failure, non-retriable, and sometimes we randomly give a temporary error, which will automatically get retried. And that is the charge function. Let's go back to the workflow, which was the order.ts. So we may not have charged the customer successfully. If we didn't, then we notify the user and fail the workflow. If we did successfully charge them, we change the state to paid, and then we await a condition. So in TypeScript, the condition API takes a function that it repeatedly, whenever there's a new activation of the workflow, checks whether this is true or not after like signals are processed. And if it ever is true, then the promise will resolve, and it'll return true, resolve to true. And if it ever hits this timeout of 1 minute before this predicate becomes true, then it will resolve to false. So if we negate the false, then we are not picked up in time if the minute passed while we're still in the that paid state. In which case, if it wasn't picked in time, we change the state to refunding. We call this refund and notify helper, which is at the bottom of this workflow file. And that calls two activities, refund order, and then send push notification. So similar to the other activity, it's calling this payment service, which mocks sometimes unable to reach the downstream API with some probability. And then sends push notification. So this is this try, or sorry, let's see. So this is sort of like a saga. If there's some error that happens, we're undoing what we did before, which was the charge. So this is the compensation logic. So if we, okay, so let's look at how this becomes true. This becomes true when a user, let's look at these together. So we got the menu at the top. If we order something, it shows up here. So if I click this pickup button, then what happens? We are inside the driver app. So we'll go back up to apps, driver, pages, index. So we've got a list of orders in this order table. And we've got some functions for marking order picked up and delivered that are called by hitting the buttons down in this React code. So like on click, we mark an order picked up. And what this does is at some point we're calling the pickup mutation. Let's find where that is. Okay, so we mark it locally picked up, and we also call the mutation, which is another TRPC function. So if we look at the definition of this, we switched from the index file to the backend API file, but this time inside of driver instead of inside of menu. And we have a few different routes you can hit. There's pickup, deliver, and get orders. So get orders is the thing fetching all of these orders, and pickup is what's called when we click the pickup button. And what it does is validates that it's receiving a string, which should be the order ID. So we're renaming it order ID right here. And we have the temporal client, and we call workflow.getHandle. So now we have the handle to the workflow, and we signal it with the picked up signal. And then in TypeScript, we use these for type safety, where usually you'd have some input. In this case, we don't have any input. Okay, so once where is our order? All right, so once the workflow receives this signal, this will be called. The state will change to pickup, and then all the conditions will be evaluated, and this will be true. So we'll skip over all of this, and then send a push notification to the user saying their order was picked up. And then we'll go on to the next condition, which has a race between 1 minute timeout or the state becoming delivered. Similarly to the pickup, the front end menu, you'd hit the deliver button. That would go to the TRPC backend serverless function, and that would over here, and that would call hit this deliver function and then call the delivered signal, which would do this handler and change the state to delivered. And then once the workflow runtime finishes processing signals, it checks conditions. This condition would then be true. We wouldn't go through this compensation. Instead, we would say, hey, user order was delivered. Then we'd sleep for a minute and then send a push notification saying, can you rate your meal? One note on this list right here, let's look at how that is coded. So if we look at the index, it's displaying an order table. An order table has a list of orders that it has from the get orders endpoint. And we're asking it to refetch the list every second. So let's look at the definition of this. So we've got the temporal client again, and we call workflow.list with this query, just like I only want to fetch order workflows, not other types of workflows that may be on in this namespace. And then I create a list of promises, and then I'm doing for await because this is a async iterable. And if any of the workflow statuses are terminated because I was debugging something and don't want to show it, then it skips it. And then if I've gotten the most recent 30 things, I'm gonna stop fetching more. So this list only displays the maximum of 30 things, 30 orders. And then I add to the promises this async function that returns a promise. It starts out with the workflow ID and uses the TypeScript client to get that workflow and then query it with the get status query. And remember, this returns an order status, which has the product ID, the state, and the delivered at. So this is what we're using we're not displaying the delivered at timestamp, but we're using the product ID on the front end to look up the description and image and title. And we're using the state to display this failed or delivered. So going backward, we awaited that query. So what that did under the hood was sent the query to the server. The worker picked it up. Let's look at that. Worker picked up the query task and called this query handler, which was really simple and just returned these variables, which went back to the server, which went back to the server front end, which went back to this client via gRPC, and then this await resolved into that object. So this status object, you can see is the type order status, and we're returning it so that we get at the end of the promise. And now we're awaiting all of the promises that we pushed onto this array while we were getting results from the iterable, and then we return them. And that's what gets used to display the list. Now let's look at the web UI. Oh, I'm in incognito. Never mind. Let's see. I can do it off screen and then bring it over. I'm logging into Temporal Cloud, which has web UI and a new top navigation in case you haven't seen it. So this is my temporal dev namespace, and all of these are order workflows. And we can match up with here, like, okay, what's the order number 2EC? That's going to be this one right here, this workflow. And we can see why it failed. So we start out at the beginning, execution started, we charge the customer. I'm looking at this activity type here. finished, so that the charge customer activity task finished. Then we started that 1 minute timer. You can see that's 1 minute here, and then it was signaled because we clicked the pickup button, and then the timer is canceled because like the condition now knows I don't need this 1 minute timer anymore because I just tested the condition and it's true now. Then we set up that we send the send push notification activity that completes. Then we start a new timer, the 1 minute for, like this needs to be delivered within 1 minute or we cancel the order. And then it fires. So there's no signal between this timer started and this timer firing. So the delivery didn't happen. So the workflow gets reactivated and the condition returns false and we start doing our compensation. So here's the activity. We're starting the refunding of the order. That completes here. I'm not returning anything from these functions, which is why data is null in the response. We did the refund order activity. Now we're doing the push notification activity. That completes. And then once we get back, we throw an application failure saying it was not delivered in time. So that's an example of a failing order. Let's look at a successful order. This was for item number 2. So let's match this up. The workflow ID / order ID is 463. So if we look here, 463 was this one for Barada. So I guess this is product ID number 2, and it was delivered successfully. So we're in the completed status. If we do a query, get status, we see state is delivered. Delivered at timestamp and the product ID. So if you go back to history and look through what happens, we started the workflow again with just the product ID as input. Charged the customer activity. Started the timer to race against the signal. We got the signal right here, which is the picked up signal. And then let's look for the next signal. Here, we got the delivered signal. So we canceled the 1 minute timer. And sent push notification. Let's see if any of these activities didn't. This is attempt number 1, so this activity was fine. I'm looking for an example of also fine. Sometimes the activities fail and they get automatically retried, which I imagine most of you are familiar with happening and what it looks like in the UI. Cool. So that is how the history looks from the workflow that's backed by this code. We've looked at the activities and the worker and the driver and the menu. Let's check back on the blog post. I recommend checking it out. It goes into some more detail. And there's also it's also a great way to intro other JavaScripters or TypeScripters if you would like to spread the good word of Temporal. And in part 2, I go over sort of how Temporal works. So on our website, we have this how Temporal works diagram, which goes through the process of starting a workflow or executing a workflow and then getting the result in Go. And I sort of do something similar that you can get this from getting started and how Temporal works. I do something similar in this post with TypeScript code, the code from that we just looked at. I talk about the different parts, client, server, and worker. Client tells the server to do things. Worker picks up tasks and runs your code. Yeah, and so I go through some more diagrams of the order of communication and when it happens. Activity failure error. it'll pick up a new task, or it can get retried. And then I go through like what happens if the worker dies in the middle and has to request the history of the function from the server, and then it replays all of the code, but instead of actually calling the activities during the replay, it takes the results of the previous activity tasks that the activities that completed in the past that I know because I looked at the history and I saw activity task completed in my workflow's history. I take the result from the activity task completed task or event and substitute it in the return value of condition. So instead of setting a timer, and so this is like from the workers, the runtime perspective of how it's running your workflow. The condition is a function that gets imported from the SDK. So it can decide what to return and when to resolve. So instead of setting a timer, it just immediately returns true because it knows that there's a signal in this case. But similarly, if this was an activity call, it would, instead of calling activity or telling the server to call the activity, it would take the result from the activity task completed and return it immediately. Yeah, similarly, I go through event history and how it lines up with what happens, and that's it. Are there any questions? Yeah, Arc. Arc is a browser. I highly recommend. Let me know if you need an invite. If you have any other questions after this or want to chat, I'm at LaurenDSR on Twitter. My DMs are open. People are hungry. Any other questions for me about TypeScript SDK or Temporal in general?
And also, please don't forget, you can also reach Lauren on our public Slack. So if you have not done so yet, please do sign up for it.
Any new upcoming features you can speak to from Brad? So update, in case you missed it earlier, is a way to send an RPC. You can have an argument, and it can mutate workflow state, and it can return a value to you. So currently, in order to get that behavior, I would have to send a signal and then pull and then send a query and make sure that the signal is processed before I get the query results. So this can happen in one request, and it also can do so with less latency, lower latency than signal. Yeah, let alone signal and query. So that's a big one. There's also schedules. If you haven't done it, is a better cron that you can edit after you've created, and has lots of different features and has good SDK support. I don't know if it's reached all the SDKs yet, but it is in TypeScript. Yeah, so the synchronous signal is the update feature I was just talking about. ETA on synchronous update. So you can check out the release notes for server 120 in temporal.io/temporal. And we have, it's an alpha in the server right now, I think behind maybe a flag, and the alpha of the Go SDK is published. Another upcoming feature that I'm looking forward to is better versioning for workflows based on some new interactions between the worker and server. I'll hand it back to Dominic.
Awesome. That was a point landing just in time. Also, my voice came back just in time. I don't know where that went. So thank you very much. Thank you very much, Lauren. Thank you very much, everybody, for joining. Great meetup, as always. And I am very much looking forward to see you all next time, next month. Thank you very much and have a great day. Bye-bye.